When you're graphing inequalities from standard form, this can be a little bit trickier than slope-intercept form. With slope-intercept form, since y is already isolated, the greater than or less than symbol will hold true for the shading. However, when you're doing standard form, it may or may not match the original inequality statement because inequalities can flip when you multiply or divide by a negative. They should flip when you multiply or divide both sides by a negative. So when you're graphing standard form, you want to make sure that you do check a point on one side or both sides to verify if it does or does not make the statement true. Now you can graph either using your x and y intercepts, or you can graph by converting to slope-intercept form. But just remember, if you do convert to slope-intercept form and you multiply or divide by a negative, so that means if your y coefficient is negative, your symbol is going to flip. And so that will impact the shading. It shouldn't be an issue as long as you check your points. So looking at here, if we have 4x plus 2y equals 16, on this one, I could find my x-intercept by making y 0. So I could say, well, if it was 4x, and I'm just going to pretend it's an equation for now, 4x equals 16, then the x-intercept would be when x is 4, because I would divide both sides by 4. So on my x-axis, I could put a point at 4. For my y-intercept, if x were 0 and I had 2y equals 16, then y would equal 8. So on my y-axis, I would be at 8. Now, since my symbol is or equal to, I would connect those using a solid line. So that's one way to graph the line itself. The other option would be to say, well, I'm just going to go ahead and convert this to slope-intercept form. So I'm going to subtract my 4x, and that's going to give me 2y is greater than or equal to 16 minus 4x. Then I'm going to divide everything by 2. That's dividing by a positive, so it won't impact the inequality. And I would have 8 minus 2x. So now I should have a y-intercept of 8, which I already found earlier. And my slope would be negative 2. So if I look at this line, down 2 over 1, down 2 over 1, down 2 over 1. Yes, that's the slope that I had even using my intercepts. But sometimes the intercepts are not super friendly, and we would want to convert to this format. Now, looking for a point to shade, we're going to check, since it's greater than or equal to, I would start by checking above. I'm going to go with 5, 5. I like for x and y to be the same value because then I don't have to worry about which one's which, right? So 4 times 5 plus 2 times 5 is greater than or equal to 16, and we want to see if this is true. So 20 plus 10, is that greater than or equal to 16? Well, 30 is greater than or equal to 16. Yes, that is true. And so I would want to shade the side where 5, 5 was. Had I tried maybe 0, 0, and I plugged in 4 times 0 plus 2 times 0, that would be 0 is greater than 16, and that's definitely false. And so the other side of the line would not be where I would shade. But here it's just going to be really crucial to check a point and make sure that you shade the side that is true. So this one here, if I had to graph 2x minus 3y is less than or equal to negative 16, notice that my y term is negative. So if I were to try to get this solved over to slope-intercept form, so if I subtracted 2x, then negative 3y would be less than or equal to negative 2x minus 6. Then I'm dividing by a negative, so y is going to be now greater than or equal to, because the symbol will flip, 2/3 x plus 2. So that symbol will flip, that will impact the shading. If I was doing the intercepts, your x-intercept when y is 0 would be negative 3, and your y-intercept would be positive 2. And you can see there from positive 2 that would be a slope of 2/3. It is or equal to So I would draw it as a solid line because it can be equal, so the line is part of the solution. Now to check the shading, I did flip the symbol, but let's say you forgot to flip the symbol, and maybe you thought, let's try 0, 0 first. It's really important here that you always want to check your original inequality in case you made a mistake solving it. We wouldn't want to keep that mistake while we're checking. So always go back to the original inequality. So that's going to be that 2x minus 3y is less than or equal to negative 6. So if I did 2 times 0 minus 3 times 0 is less than or equal to negative 6, is 0 less than negative 6? No, that's a false statement. And so then I would think, well, maybe I was supposed to flip my symbol. And hopefully that would help you catch those types of mistakes. So if I check a point above the line, let's say I check 0, 6. Then I'm going to be doing 2 times 0 minus 3 times 6. Is that less than or equal to negative 6? And so 0 minus 3 times 6 would be negative 18. Is negative 18 less than or equal to negative 6? Yes, it is. So this is a true statement, and therefore I would shade the side that included the 0, 6. All of those ordered pairs should also make the inequality true. They're all part of the solution set. Now on this one, if I went to try to find my intercepts, my y-intercept is 6 because when x is 0, that's easy. But then my x-intercept would be like 6/5, and that's not going to be very easy to graph. So this one is definitely going to be a better choice to go ahead and subtract 5x and get it to slope-intercept form. So y is less than 6 minus 5x. On my graph, I'll start at 6, and then I'll go down 5 and over 1. Down 5, over 1, down 5, over 1. And since it is not or equal to, I would just do this as a dotted or dashed line. I would not make it solid. Now, it should be less than, so I'm going to check 0, 0 by plugging in 0 for x and y to that original equation. So 5 times 0 plus 0 is less than 6. That's 0 is less than 6. That's a true statement. So the points that make this inequality true would be all points, all ordered pairs on this side of the line, which is less than that line. So that's how you would do standard form. You would want to make sure that you check a point for the shading, and you can go to slope-intercept form. Sometimes you need to because of the way the ordered pairs work for the intercepts. Or you can graph the intercepts, but the shading would come from checking to see which side is true.